Okay, in 6.6, we are talking about our last two quadrilaterals, and those quadrilaterals are the kite and the trapezoids. So we're going to talk about those properties of both kites and trapezoids. And kites and trapezoids, I want you to remember, are not parallelograms. These are not parallelograms. They do not have two sets of parallel sides. A kite, the definition of a kite is that it has exactly two pairs of congruent consecutive sides. So consecutive means right next to each other. So these two sides will be congruent, and those two sides will be congruent. And there are two special things about the kite. The first thing is that the diagonals will be congruent to each other. So if you know something is a kite, that means that the diagonals will always be congruent. So if you drew diagonals here and diagonal here, they will always meet at a right angle. So I want you to get into the habit of drawing in that right angle. The second special property is that if it's a kite, that means that one set, only one set of opposite angles will be congruent to each other. And those opposite angles are always the ones that meet the two different sides. So angle B meets two different sides. This one is a different length than this one, and angle D meets two different sides, so this one is going to be congruent to this one. So this angle will be congruent to this angle. Now, that's important, and I want you to also write that down whenever you see kites, because the reason why I want you to fill in that information is because it'll help you figure out the missing angle lengths. So it says kite ABCD. So right away, I want you to say, well, these sides have to be congruent to each other. These sides have to be congruent to each other, and we know that the diagonals are perpendicular, and we know that angle B has to be congruent to angle D. This will help us solve our problem. It tells us that DAB is 54 degrees. So DAB, that's this whole angle right here, is 54. And CDF, that's this part of the angle, is 52 degrees. And they want you to work and find what BCD is. But I'm going to make you, instead of just finding this angle, I want you to figure out what all the missing angles are. So the reason why I want you to fill in all this information is because you can either look at isosceles triangles. We have one isosceles triangle at the top, and we have one isosceles triangle at the bottom. And if you remember, for isosceles triangles, that means that we have two sets of sides that are congruent, so those base angles are going to be congruent to each other as well. So if you look at this isosceles triangle, if this angle is 52 degrees, that means that this angle also has to be 52 degrees. So that's one missing part that we just figured out. Okay, so you can use isosceles triangles in here to figure out the angle measures. I'm going to use isosceles triangles the entire time. If this is 52 degrees and this is 52 degrees, I'm just looking at this one isosceles triangle. Well, you know that there's 180 degrees in all triangles, so 52 plus 52 is 104. And subtract that from 180, you know that this third angle in this isosceles triangle has to be, has to be 76 degrees. All right, now we have a bottom isosceles triangle. For the bottom isosceles triangle, we know that the vertex, this is 54 degrees. And we know that this angle has to be congruent to this angle. So what you can do here is subtract it from 180, and you get 126. And you know these two angles have to be the same. So if you take 126 and you divide it by 2, that means that each angle has to be, what, 63 degrees? 63 degrees. So this angle is 63 degrees, and this angle is 63 degrees. All right, so we just found out what all the angles in this kite are. And to check your work, remember it's a quadrilateral, so if you add up all the angles, A, B, C, and D, they have to equal 360 degrees. So let's check our work. We know angle A is 54 degrees. We know angle C is 76 degrees. We know angle B and angle D are congruent to each other because it's a property of a kite. And let's see, 63 plus 52 is 115 and 115. And if you add all those up, you should get 360 degrees. If you don't, you did something wrong. Okay, so I just used isosceles triangle to figure out all these angles. What happens if I want to figure out what just this one angle is? Well, the other way you can do it is to use right triangles. So let's see if we can figure out right triangles, figure out what it is using right triangles. So we know that the diagonals bisect. This was what, 54 degrees? Yeah. We know that the diagonals are perpendicular, so this is a right angle as well. If I want to know what just this angle is, I know this angle is 63 and this one's 90, and in a triangle they all add up to be 180. So 90 minus 63 gets you 27 degrees. So notice this one is 27 degrees, and the whole thing was 54, so what does this other one have to be? 27 degrees as well. That's interesting. Let's see what happens to the other angle. So this 76, we know, again, angle B and angle D are congruent to each other. A and C are not congruent to each other. And we just split up 54 and said that both of them were 27. This is an angle bisector on this angle. Let's see if it's an angle bisector on the other one. So looking just at the right triangle this time, we know that this is a right angle, that's 90 degrees. We know that this angle is 52 degrees. So what's 90 minus 52? That's 38. So this angle is 38. The whole angle is 76. So 76 minus 38, oh my gosh, that's 38 degrees too. So there's lots of cool things that happen to the kite. What we just realized is that the angles that are not congruent to each other are going to be bisected by the diagonal. All right, so let's try that one more time in a different example. So this one, we have a kite. They tell you it's a kite. They have the congruent sides, so now I want you to say that the diagonals are perpendicular to each other, put that right angle, and we know that angle P has to be congruent to angle R. And we know that this is a angle bisector, so we know this angle has to be congruent to this angle, and this one is going to be equal to this one. Okay, so filling in what we know. They tell you angle PQR, that's this whole angle, is 78 degrees. And they tell you TRS, that's this one, is 59 degrees. And they want you to just find QRT, this one. Let's see. They just want you to find this one. So, well, there's a couple different ways you can do this. You can look at isosceles triangle. If you want to do isosceles triangle, we know that the vertex angle is 78 degrees. And we know that these angles have to be congruent to each other. And we're trying to find this angle right here. That's this one. I just redrew it for you because this is an isosceles triangle. Or you can use the fact that we know this is an angle bisector. So 78 degrees divided by 2, that means that just one angle is going to be, what is it going to be? 39? Yes, 39. So this one angle is going to be 39, and we know that this small triangle right here is a right triangle. So this one's 90, this angle is 39. To find that one, you subtract 90 minus 39, because all angles add up to be 180 degrees, and we get, what, 51 degrees. So this angle is 51 degrees. You can always check your work. This one also has to be 51. This one also has to be 59 and 59. And let's see, if this one's 59 and this one's 90, what does this one have to be? Well, 90 minus 59 is 31. So if this one's 31, that means this one has to be 31. Again, R and P are congruent angles. Q and S will then be bisected. 39, 39. 31 and 31. Angle R and P, since they're congruent, they are not being bisected. Notice this one's 51 and this one's 59. There's lots of intricacies to the kite. All right. Yeah, and that's about all we're doing for the kite. The next one is for the trapezoid. Trapezoid has, the definition is that it is a quadrilateral. That's good, important to know. 4 sides, and it only has one pair of parallel sides. Again, a trapezoid is not a parallelogram. Some important vocabs. The parallel lines are going to be called bases, and the ones that are not parallel are going to be called legs. And the two angles that are on the same parallel line, those are called base angles. So this one and this one is a base angle to each other, and these are another set of base angles. So that's some common vocabulary for a trapezoid. Now we're going to be talking specifically about an isosceles triangle. Oops. I want that one. Isosceles means we have two sets of congruent sides. So for an isosceles triangle, that means that the legs have to be congruent to each other. And then the bases are parallel. Sweet. If we have an isosceles trapezoid, just like when we have isosceles triangle, that means that the angles opposite of it are going to be congruent. So the first property is that if we know it's an isosceles triangle, that means that the base angles will be congruent. They're a set of base angles. So this is one set of base angles. This is another set of base angles that will also be congruent to each other. All right, I'm going to put a double arrow because that means if you know that a quadrilateral has base angles that are congruent to each other, it must be an isosceles trapezoid. The second part is that if you have an isosceles trapezoid, that means that the diagonals will be congruent to each other. Diags congruent. And again, I'm going to put this biconditional arrow, meaning that the reverse is true. If you have diagonals that are congruent in a quadrilateral, not a parallelogram, in a quadrilateral, that means that it will have to be an isosceles trapezoid. Okay, so those are the two special things about isosceles trapezoids, and these questions are a little bit easier than the kites. They're wanting you to find an angle in this one. I want you to find all the angles. Well, it's an isosceles trapezoid because we have two legs that are congruent, so the base angles are going to be congruent, the ones that are on the same parallel line. So if this is 100 degrees, that means this has to be 100 degrees. Now, if you get rid of this transversal for a second, we have parallel lines. Parallel lines. Boom, 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 boom. Boom, 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 boom. So that means everything we talked about in chapter 3 is will occur in this picture. These angles are same side interior angles. So that means they're going to be supplementary. And they're going to add up to be 180 degrees. So if this is 100 degrees, that means that this has to be 80 degrees. And now if we look at the whole isosceles trapezoid, we know that these angles have to be, these base angles have to be congruent to each other, so it's 80 degrees. And these base angles have to be congruent to each other, so that's 100 degrees. To check your work, remember it's a quadrilateral, so if all angles add up to be 360 degrees, that means you did it correctly. So in this case, 100 plus 100 plus 160 does equal 360 degrees, so you did it correctly. I can make these questions harder by asking you to solve for a value. And it says solve for the value of A so that PQRS is an isosceles trapezoid. So if we want it to be an isosceles trapezoid, that means we know that the base angles have to be congruent to each other. So to solve it for A, we could say A squared plus 27 equals 2A squared minus 54. And some people are going to freak out because we have an exponent. It's okay. Move so that the variable is on the same side. We only have one variable. That's the A squared. And this is going to become 1A squared. Add the 54 to isolate the variable. And you're going to get 1A squared equals 81. To get A by itself, you have to do the square root. You have to do the radical. Now remember my trick. If you have an exponent of 2, how many answers should you have? You should have 2. So when you do the square root of 81, it's not only a positive 9, it's also a negative 9. Some people are like, well, how can you have a negative angle measure? We don't have a negative angle measure. If you plug in negative 9 here, negative 9 squared will be a positive 81. Multiply it by 2, subtract 54, you're going to get a positive angle measure. If you get a negative angle measure, then you did something wrong. The third type of question I can ask you for trapezoids, isosceles trapezoids, deal with their diagonals. Remember, in isosceles trapezoids, sorry, I'm so used to saying triangles, we know that the diagonals are going to be congruent. So, looking at this information, they tell you MF, that's the entire diagonal, is 32.7. So that means that this entire diagonal also has to be 32.7. So we know KJ equals 32.7. Now, they also tell us that KB is 21.9. 21.9. So what do you think BM has to equal? Well, it also has to equal 21.9. If we want to just find out what the leftover piece is, all you're going to have to do is subtract. We know the whole thing is 32.7 and the larger part is 21.9. So you're going to subtract and figure out what the remainder is. So 32.7 minus 21.9 gets us 10.8. So our answer for this one is going to be 10.8. So these pieces are also congruent to each other. So those are the three types of questions I can ask you for the isosceles trapezoids. And the very last thing we're doing in this section deals with the mid-segment of a trapezoid. Now, in Chapter 5, way back when in Chapter 5, we talked about the mid-segment of a triangle. A mid-segment connects two midpoints. So I have the midpoint of this side of a triangle, and I'm going to connect it with the midpoint of this side of the triangle. And we learned in Chapter 5 that if the base, the opposite side, is 10, then the mid-segment is going to be half of it, 5. And the reason why we did that is because we found the average of the opposite bases. So if this side was 10 and this side was 0, to find the average, you add them up and divide by the number of sides. So in this case, we took a 0 and 10, so we divide by 2, and that got us the 5. That's what you guys did, and you didn't even know it. For a trapezoid, we are going to have, we're going to do the same thing. So let's say, for example, that this side was 2 and this side was 10, and I wanted you to find the length of the mid-segment. Well, you're going to add up the two opposite bases and divide by 2, since we're talking about two bases. And that would be that the mid-segment would be 6, because 12 divided by 2 is 6. So that's one question I can ask you. Another question I could ask you is I actually give you the mid-segment. So remember what we just did. The mid-segment equals the sum of the bases divided by 2. And remember, the bases are the parallel sides. So this is a base and this is a base. If you need to work backwards, what you do is just plug in your notes. You know the mid-segment is 16.5. You know that one base is 25, and we don't know what the other base is, and we have to divide it by 2. So what's the opposite of dividing by 2? Multiplying by 2. So you're going to multiply the mid-segment by 2. 16.5 times 2 is 33. That gets rid of this fraction, and now we are just left with the numerator, 25 plus 4. Plus b, excuse me. And then to get the base by itself, you subtract 25 on both sides. So the second thing is you subtract, and that gets you that the base is 8. Now to check your work, all you guys are going to do is what we just did before. This mid-segment is 8, and this mid-segment is 25. Just find the average. So 8 plus 25, that's 33. Then we had two bases, so divide it by 2, and bam, we get 16.5. All right, those are the three things that we talked about in this section. We've got the kite, we've got the isosceles trapezoid, and then we've got the mid-segment of a trapezoid. Nice job.